Hello, Mary. So I got your text and all your questions. So one of your questions is on page 302, number 17, and I believe it's practice 8.8. So it's this problem right here. So I'm going to run through this problem with you, okay? And then you also said that you had problems with numbers 13, 14, 15, and 16 on page 302 in the review. And numbers 13, 14, 15, and 16 are all the same type of problem. So I'm going to do one of those problems with you, and then from that explanation, I want you to try to do the other three problems, okay? All right, let's go ahead and get started with number 17 here. We've got the square root of 1 minus 3m minus m equals 3. So the first thing we need to do is we need to get the radical, the square root, by itself on one side. So what I need to do is get rid of that negative m. So to do that, I'm going to add m on this side and add m on that side. Because whatever I do on one side of the equal sign, I have to do on the other side to keep the equation balanced. So what does this give me? This gives me the square root of 1 minus 3m. Right? Negative m and positive m is 0. And then 3 plus m. In fact, I'm going to use the commutative property. And I'm going to say m plus 3. Okay? M plus 3, 3 plus m, the same thing. Okay? So then I need to get rid of the radical. And to get rid of the radical, we have to square it. Okay? So I'm going to square the radical. And if I square this side of the equal sign, I have to square this side. All right? Now, when we square m plus 3, what is that? Well, that's just m plus 3 times m plus 3, right? And that equals m squared plus 6m plus 9. And we get that by foiling m plus 3 times m plus 3. We just use FOIL. F-O-I-L, first, outside, inside, and last. Okay, we learned that earlier in the year. So, when I square it, my square root of 1 minus 3 becomes 1 minus 3m, and that's going to equal m squared plus 6m plus 9. All right? So then what I'm going to do is I'm going to subtract, let's see here, what am I going to do? What I'm actually going to do, I'm going to subtract 1 from this side, and therefore I'm going to subtract 1 over here, okay? And so what that's going to equal is, it's going to leave me with a negative 3m on this side, and then I'm going to have m squared plus 6m, and then I have a positive 9 minus 1 is positive 8. And then I'm going to add 3m to both sides. All right. What that's going to leave me is 0 equals m squared plus 9m plus 8. Now this should look familiar to you. Because remember when we were doing quadratics, all right, this is a quadratic equation, all right? When we do quadratics, if we factor this, then we can have two values for x, right? Because when we factor this, I'm going to have two binomials, and if one binomial equals 0, then the whole thing is going to equal 0. And if the other one equals 0, it equals 0. So what we have to do is we have to factor this. So 0 equals m. Okay, we need two numbers that multiplied together give us 8 and added together gives us 9. So that would be m plus 8 and m plus 1. All right? So we need to solve each one of these binomials to see what m would equal to make this equal 0. So if this binomial equals 0, m plus 8, if that equals 0, then 0 times m plus 1 is going to equal 0. And if m plus 1 is 0, then 0 times m plus 8 is going to be 0. So m equals either -8 or -1. Because if I replace m with -8, -8 plus 8 is 0. And then -8 plus 1 is -7. So I would have 0 times -7. And anything multiplied by 0 is 0. Okay? So that's a possible answer. The other possible answer is -1. Because if m equals -1, if I plug that in, I would have -1 plus 1. What does that equal? 0. And 0 times, what's -1 plus 8? Well, that's +7. So 0 times 7 is still going to equal 0. So m actually has two possible answers. And that is the answer to number 17. Now this should be familiar to you because when we did quadratics, we went over that. Okay? That's how we find different values of the variable, right? By factoring the quadratic and setting it equal to 0. Okay? We went over that earlier in the year. So that's how we do number 17 on page 302. Now, let's look at the review. So, review number 13. We're going to do number 13 together here, and then I want you to do 14, 15, 16 on your own. Okay? Because they're all the same problem, or same type of problem. So, 13 says the fourth root of 81 x to the fourth. Okay? Now, there's a rule here that if an exponent on the inside of the radical is equal to or greater than the index, this is the index, then you can pull that factor out. All right? So if I had the square root of x squared, right? The index is 2 on a square root. That equals x. The cubed root of x cubed, these are the same. Those are the same. If they're the same, then it's just the base. Right? The fourth root of x to the fourth, they're the same. That equals x. Does that make sense? All right. So, what if I had the fourth root of x to the fifth? Well, I can factor x to the fifth. If we use our rules for multiplying exponents, I can write this as the fourth root of x to the fourth times x. X to the fourth times x is the same thing as x to the fifth. And here again, I have x to the fourth, my exponent, equals my index. So, if my exponent equals my index, I can pull that root out. So that would be x times the fourth root of x. Okay? If I have cubed root of x to the 11th, all right? What I can do is I can factor this, where I'd have the cubed root of x cubed times x cubed times x cubed times x squared. If I multiply all of those, right? All you have to do is add the exponents. So the exponents would be 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 2 is 11. Okay? And remember, if an index is the same as your exponent, I can pull the base out. So that would equal, I've got this one, I've got x cubed. That's the same, so I can pull that base out. So I'd have x, all right? And then I have this guy here, that's another x cubed. So this is equal to that, so I can pull out another base. Then I have a third one, where the exponent is equal to the index, so I pull that base out. And then what's left, if your exponent is less than your index, you can't pull it out. So you have to leave it in there. So then I would have times the cubed root of x squared, right? And then this right here is what? X times x times x equals x cubed times the cubed root of x squared. Actually, let me write that better. X cubed times the cubed root of x squared. Okay? If you remember, you have the index, you have your base, and you have your exponent. Right? That equals x to the exponent of b over a. Right? The exponent over the index. All right? So if we look back at this, all right, we could do it a different way. What if we just did the cubed root of x to the 9th times x squared? Well, we know from this rule that x to the 9th, the cubed root of x to the 9th is x to the 9 over 3 times the cubed root of x squared. What's x to the 9 over 3? Well, 9 over 3 is 3. So that equals x cubed times the cubed root of x squared. It's the same thing. All right? So that's how we deal with these simplification problems. Okay? So in number 13, you have x to the 4th, and you have an index of 4. So they're the same thing. So we can pull out the base. Right? So I can rewrite that as x, I take that out of the radical, times 81. Now, we need to factor 81. We need to prime factor it. Okay? So I'm going to take 81 over here, and I'm going to prime factor it. Now, we always start with 2, but 2 doesn't go into 81 evenly. All right? So we go to the next prime number, which is 3. So 3 into 81 goes 27 times. All right? 3 times 27 is 81. Then we prime factor 27. Well, 3 goes into that also. 9 times. 3 goes into 9 3 times. So 81 equals 3 times 3 times 3 times 3. Which also equals 3 to the 4th power. Okay? 3 times 3 times 3 times 3 is 3 multiplied by itself 4 times. So that's 3 to the 4th. So I can rewrite this as x, the square root of 3 to the 4th. I'm sorry, I forgot my index there. All right, got to keep the index. All right? So you can see how we got the x out, right? So it's just x, and that's not x to the 4th. That's x times the fourth root of 81. And then we prime factored 81. And so we've got, let me just rewrite this, that'd be x times the fourth root of 3 to the fourth, because 3 to the fourth is the same thing as 81, right? I just showed you here. So here again, our index and our exponent is identical. So I can pull the base out. And what's the base? Well, the base is 3. So that's going to equal 3 times the x that we already pulled out. Okay? So the fourth root of 81 x to the fourth equals 3x. Okay? Hopefully you followed that and followed how we deal with exponents underneath a radical and its index. Okay? So let me do, I'll do 14 with you. Let's do 14 as well. All right, so that was 13. So let's look at number 14 as well. So 14 is the fourth root of 16 x to the fourth y to the eighth. All right, so let's look at our first variable. We got x, and that exponent of x is identical to my index. The exponent is the same as my index. So what does that mean? You just pull the base out, right? So I can write that as x times the fourth root of 16 times y to the eighth. Okay? So now let's look at the other variable. We have y, and the exponent is 8. The index is 4. So we know using this that y, the fourth root of y to the eighth, so the fourth root of y to the eighth is the same thing as y to the 8 over 4. The 8 divided by 4. Well, what's 8 over 4? Y squared. Right? So I can pull out a y squared, right? Because the fourth root of y to the eighth equals y to the 8 over 4, which is y squared. So now I can rewrite it as x times y times the fourth root of 16. Well, what's the fourth root of 16? I don't know. So I've got to prime factor 16. So let's prime factor 16. We start with 2. 2 goes into 16 evenly, so 2 into 16 is 8. 2 goes into 8 evenly 4 times. 2 goes into 4 evenly 2 times. So 16 equals 2 times 2 times 2 times 2, which equals 2 to the fourth power. So I can rewrite this as x times y times the fourth root of 2 to the fourth power. Well, that's awfully convenient because my exponent is the same as my index. And I know when my exponent is the same as my index, I can just pull my base out, right? I just pull that 2 out. So the fourth root of 2 to the fourth is 2. So that's going to equal 2 times x times y. And that's your answer. Okay? All right, so now that I went over numbers 13 and 14 with you and showed you these rules, okay, you need to study this. I want you to do 15 and 16 on your own, okay? Let me know how you do with that. All right. Give me some more questions if you have them. Thank you, Marion. Bye.